All right, today we're going to talk about scatter plots and lines of fit. Scatter plot just shows the relationship between a set of data with two variables. We've seen them before. You saw them last year. It's comparing two variables and what's happening with the data. You don't have to write this down, but pay attention. If you want to, you can. You can draw a cheap little graph. This is what a positive relationship looks like. It's with the dots. The farther to the right you go, the higher they get. This is what we call a positive relationship. What that means is x gets bigger, y is getting bigger. In pre-algebra, I talk about, which we just used this part of the graph, but in pre-algebra, I talk about like time spent doing something versus grades. Well, time spent studying, right, is going to most likely you're going to have higher grades. So that's a positive relationship because it positively affects x. It positively affects y. X is your independent. Y is the dependent. It depends on what x is doing. In a positive relationship, as x gets bigger, y gets bigger. A negative relationship looks like this. That just means as x is getting bigger, and you can see as it goes to the right, the y is getting smaller. This is a negative relationship because as x gets bigger, it negatively affects the dependent variable, which is y, and it makes it smaller. Which, again, we just work with this quadrant for pre-algebra, where I talk about time spent playing video games versus your grades, right? The longer you play video games, the less you study, the less you do your homework. More likely your grade will suffer because of it. And you can see that as a pattern, right? The more time you spend doing the independent variable, your x, the less time you get to study for your grades or you're doing homework, so your grade will suffer. That's your y. No correlation just means dots are everywhere. It just means that x doesn't affect y. Usually they're not related. They don't affect each other. An example of this would be eye color versus age. Does your eye color affect your age? No. Does your age affect your eye color? No. So if you plot those 2 points, those data points on the graph, you're going to see that those don't affect each other. All right, you're going to see a problem like this. What correlation does this graph have? Is it positive, negative, or no relationship? This is positive. As x gets bigger, y gets bigger, because the longer you work, the more wages you get, right? The more you get paid. So this would be a positive relationship. All right, write this down. All this says is just the definition of line of fit. They call it a trend line. It models the trend of the data. What's the data doing? Usually it's right in the middle of all the data points. You can kind of say it's kind of the average. It's showing you what's going on with the data. Does it always show everything? No. Sometimes you have what's called outliers, where it's way above the rest of the data, or it's way below. If everybody's going to get 70s and you have this one person that got a 0 on a test, that's called an outlier. It doesn't really show what the data is doing. It's just kind of it's a person that kind of goes against the trend. So here, wages and hours, you see as hours gets bigger, wages getting bigger, so I can model that using a trend line that kind of goes right through the data. What you're going to see today in your homework is somewhat like this. Sometimes they'll give you graphs, sometimes they'll just give you just words to describe a relationship, and you're supposed to figure out if it's positive or negative or no, and then you got to model, you got to talk about it, talk about what's going on. And then there's a couple problems that'll ask you to refer to a scatter plot. They're going to give you a scatter plot, and then they're going to give you points to write a slope-intercept form, which they'll give you an x and y, and then they'll give you x2 and x and y2. And then it's going to say find that as a slope-intercept form. Well, we know how to do that, right? You go y2 minus y1 over x2 minus x1. Get your m, plug those in, then we find our y-intercept, and then you're done there. Hey, and then it's going to ask you to predict, hey, using that data to predict what's going to happen and that type of stuff. Guys, I'm not looking for exact numbers when you're doing this because you're going to be working with big numbers. It doesn't have to be perfect. Hey, I'm really just wanting you kind of to try to attempt to figure it out. And for the most part, you'll get it right. You might be a number off or two. I'm not going to be picky about those numbers. It's just going to be more about trying to get it right. So, but if you have any questions, feel free to ask. Here's your homework assignment, 13 and 14. Just looking at them, it asks you kind of explain a couple things. Right? You don't have to go into a bunch of detail. Just make sure you write a couple complete sentences for me.